Section 8.4, Testing a Claim about a Standard Deviation or Variance. Key concept. This section presents methods for conducting a formal hypothesis test of a claim made about a population standard deviation or a population variance. The methods of this section use the chi-square distribution. So, testing claims about a population standard deviation or variance. The objective is to conduct a hypothesis test of a claim made about a population standard deviation or population variance. Notation. N represents the sample size or the number of trials. S, lowercase s, is the sample standard deviation. Sigma represents the population standard deviation. Lowercase s squared is the sample variance. Sigma squared is the population variance. Now, what are the requirements? Well, number one, the sample is a simple random sample. Number two, the population has a normal distribution, and this is a fairly strict requirement. So for number one, you're going to state the claim and the opposite of the claim. Number two, you're going to identify the null and the alternative hypothesis. Now, the null hypothesis is the statement is assumed true until evidence indicates otherwise. The alternative hypothesis is the claim to be tested. And there's three ways to structure a hypothesis test. So, when we're talking about the population standard deviation, for two-tailed, left-tailed, and right-tailed, the null is always going to equal the standard deviation value. The alternative for the two-tail has the population standard deviation is not equal to the standard deviation value. For the left-tailed, the alternative hypothesis has the population standard deviation is less than the standard deviation value. And for the right-tailed, the population standard deviation for the alternative hypothesis is greater than the standard deviation value. And then when we're discussing the variance, then the null is always going to have the equality to some variance value. And the same thing, two-tailed, left-tailed, right-tailed, we have not equals, less than, greater than, where the alternative has the variance according to those particular values. So the alternative hypothesis is the one not containing equality. So the alternative hypothesis uses the following symbols: less than, or greater than, or not equal to. The null hypothesis is the symbolic expression that the parameter equals the fixed value being considered. Number three, you're going to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Number four, you're going to select the significance level. So based on the seriousness of a type 1 error, make alpha small if the consequences of rejecting a true null hypothesis are severe, and the values of 0.05 and 0.01 are very common. The test statistic for testing a claim about a standard deviation or variance. This is chi-squared, which is equal to the quantity of the sample size minus 1 times the sample variance over the population variance. Or we can say that this is the sample standard deviation squared divided by the population standard deviation squared. And so therefore, in part 6, we're going to find the corresponding p value or critical value, and then we also want to draw the curve and label. So for the p-value method, it's provided by technology or table A4 with degrees of freedom being n-1. In the critical value method, you're going to use technology or table A4 with degrees of freedom of n-1. And then step 7, you're going to make a decision. You reject the null if the p-value is less than or equal to alpha. You fail to reject the null if the p-value is greater than alpha. For the critical value method, you reject the null if the test statistic is in the critical region, and you fail to reject the null if the test statistic is not in the critical region. And then step 8, you're going to state the conclusion. If the original claim does not include equality and you reject the null, you would say that there is sufficient evidence to support the claim that, followed by the original claim. If the original claim does not include equality and you fail to reject the null hypothesis, then there is not sufficient evidence to support the claim that followed by the original claim. If the original claim includes equality and you reject the null hypothesis, then you would say that there is sufficient evidence to warrant rejection the claim that followed by the original claim. And then if the original claim includes equality and you fail to reject the null hypothesis, then there is not sufficient evidence to warrant rejection the claim that followed by the original claim. Okay, now equivalent methods. When testing claims about the population standard deviation or population variance, the p-value method, the critical value method, and the confidence interval method are all equivalent in a sense that they will always lead to the same conclusion. So what are the properties of the chi-square distribution? Well, first and foremost, all values of the chi-square are non-negative and the distribution is not symmetric. So you can see here it starts at 0 and we know the distribution is not symmetric. And all values are non-negative for the chi-square values. Number 2, there is a different chi-square distribution for each number of degrees of freedom. So you can see here for the degrees of freedom of 10, you can see that it's more of a skewed right. And then as the degrees of freedom increase to 20, it's becoming more of a normal distribution. And then number 3, the critical values are found in the table A4 using degrees of freedom of n-1. An important note, if using table A4 for finding critical values, in table A4, each critical value of the chi-square in the body of the table corresponds to an area given in the top row of the table, and the area in the top row is a cumulative area to the right of the critical value.